In this course, you're going to learn everything you need to get started with Python. Just be aware that I've designed this course for developers, so if you have very little or no programming experience, check out my other Python course for beginners. You can see the link on the top right corner of this video. Python is the world's fastest growing and most popular programming language, not just amongst software developers, but also amongst mathematicians, data analysts, scientists, accountants, network engineers, and even kids. In fact, it's the ideal programming language to learn first. But what makes Python so special? Here are 6 reasons. With Python, you can solve complex problems in less time with fewer lines of code than many other languages. That's why huge companies like Google, Spotify, Dropbox, and Facebook have embraced this beautiful and powerful language. Here's an example. Let's say we want to extract the first 3 characters of the text "Hello World." This is the code we would have to write in C#. This is how we would do this in JavaScript. And here's how we would do it in Python. See how clean and simple the language is? And that's just the beginning. Python is a multi-purpose language, and you can use it for a wide range of jobs such as data analysis, AI and machine learning, writing automation scripts, building web, mobile, and desktop applications, as well as software testing or even hacking. So if you want a high-paying, long-lasting career in any of these areas, especially AI and machine learning, Python is the language to put those opportunities at your fingertips. In fact, according to Indeed.com, the average salary of a Python developer in the US was over $115,000 in March 2018. And here are 4 more reasons that make Python the most desirable language. Python is a high-level language, so you don't have to worry about complex tasks such as memory management as you do in C++. It's cross-platform, which means you can build and run Python apps on Windows, Mac, and Linux. It has a huge community, so whenever you get stuck, there is someone out there to help. And it has a large ecosystem of libraries, frameworks, and tools. Whatever you want to do, it is likely that someone else has done it before, because Python has been around for over 20 years. There are 2 versions of Python out there. Python 2, which is the legacy version of Python and is going to be supported until year 2020. And Python 3, which is Python for the future. In this course, you're going to learn Python 3. Hi, my name is Mosh Hamedani, and I'm going to be your instructor in this course. I'm a software engineer with 18 years of experience, and I have taught way over 1 million people how to code or how to become top professional software engineers. To learn more about me and my courses, head over to codewithmosh.com. All right, now let's get started. All right, now we're ready to download and install Python. The first thing I want you to do is to open up your browser and head over to python.org. On this page, under the downloads, you can see the latest version of Python. Currently, the latest version is 3.7. Chances are in the future, when you're watching this video, there is a newer version available. Don't worry, all the materials in this course will continue to apply with the future versions of Python. So go ahead and download Python and then run it. If you're on Windows, you're going to see this checkbox here, add Python to path. This is very important. Make sure to tick it. Otherwise, you're not going to be able to follow the course. So now go ahead and install it. Now let's verify that we have installed Python properly. If you're on Windows, here in this search bar, type CMD, which is short for command prompt. Now here in command prompt, type Python. You can see we have successfully installed Python version 3.7. Now to exit, press Ctrl Z and then enter. Done. If you're on Mac, press Command and space. This opens up the Spotlight search. So here type terminal. Terminal on Mac is like command prompt on Windows. Now Mac and Linux by default come with an older version of Python, that is version 2. So if you type Python You can see Python 2 here. That's not what we want. So press Ctrl D to exit and then run Python 3. And this verifies that we have successfully installed Python 3.7. So this environment you see here is what we call Python interpreter. Here we have this interactive shell that is really useful for experimenting with some Python code. So here we can write expressions like 2 plus 2 or any kind of valid Python expressions. This is similar to your JavaScript console in the browser. So if you want to quickly experiment with something, you can simply do it here. But to build real programs, we need a code editor, and that's what I'm going to talk about next. To build Python programs, you have two options. You can use a code editor or an IDE, which is short for Integrated Development Environment. An IDE is basically a code editor with some fancy features such as auto-completion, debugging, unit testing, and so on. For both editors and IDEs, there are lots of options out there. The most popular editors are Visual Studio Code or VS Code, Atom, and Sublime. You can use the editor that you prefer. The most popular IDE is PyCharm, which is a JetBrains product. In this course, I'm going to use VS Code because that's my favorite code editor. And later, I'm going to show you how to install an extension to convert VS Code into a powerful IDE for building Python programs. So, if you don't have VS Code, head over to code.visualstudio.com and download the latest version of VS Code. Now with VS Code open, on the top, go to the File menu and then Open. Somewhere on your disk, create a new folder. Let's call that folder Hello World, as usual. Now open this folder. Now here on the left side, we have the Explorer panel, where you will see all the files and folders in your project. So let's add a new file here and call it app.py. Now you may see an error on the bottom right corner of the screen. Don't worry about that. We're going to fix that later in this section. So close this. Now let's write a simple Python program. Once again, I have designed this course for people with some programming experience, so you should know your variables, functions, conditional statements like if, else, for loops, while loops. You should know the basics. If you don't, please look at my other Python course for beginners. You can find the link on the top right corner of the screen. So in Python, we have a bunch of built-in functions. One of them is print, which we can use to print something on the terminal. Let's add a string here, hello world. But let's make it more fun by adding a happy Persian cat here. Now let me show you something cool. Let's add another print statement. Here we add a string, like an asterisk. In Python, you can multiply a string by a number, like 10, and this will repeat that string 10 times. Take a look. So save the changes. Once again, you may see this error popping up. Don't worry about it. We'll fix that later. Now we need to go back to the terminal to run this program. However, we don't have to constantly switch back and forth between VS Code and the terminal because here we have an integrated terminal. You can open that by pressing Ctrl and backtick. That is the key before number 1 on your keyboard. It's right below the escape button. So here's our integrated terminal. So if you're on Windows, type Python. If you're on Mac, Python 3, and then app.py. And here's the output of our program. Next, I'm going to show you how to convert VS Code into a powerful IDE for building Python programs. In this lecture, I'm going to show you how to convert VS Code to a powerful IDE by using an extension called Python. With this extension or plugin, we get a number of features such as linting, which basically means analyzing our code for potential errors. We also get debugging, which involves finding and fixing errors. We'll look at this later in the course. We also get auto-completion, which basically helps us write code faster, so we don't have to type every character. We get code formatting, which is all about making our code clean and readable, just like how we format our articles, newspapers, books to make them clean and readable. We get unit testing, which involves writing a bunch of tests for our code. We can run these tests in an automated fashion to make sure our code is behaving correctly. And finally, we get code snippets, which are reusable code blocks that we can quickly generate, so we don't have to type them all by hand. Now, don't worry about memorizing any of these. As we go through the course, you're going to learn about these features. Now, here in VS Code, on the left side, click this icon. This opens the extensions tab. So these are the extensions that we can install in VS Code to bring in additional functionality. Here under the recommended tab, you can see the Python extension. If you don't see this, simply type Python here on the top. And here's the extension. So go ahead and install this. And then you will have to reload VS Code. Now here on the bottom right corner, you can see this message, linter pylint is not installed. So as I told you before, linting is about finding potential errors in our code. Linter is a program or a tool that analyzes our code and finds these potential problems. Now for Python, there are several linters out there. Pylint is one of the most popular ones that this Python extension uses by default. So we need to go ahead and install Pylint as well. Now to do this, first we need to change our Python environment. So if you look here on the bottom left corner, you can see the current Python that is used in VS Code, that is Python 2.6.9 on my machine. Chances are you see a different version here. So click here, and in this list, make sure to select Python 3.7. So this changes our Python environment to Python 3.7, and then we can install Pylint by clicking this button. Okay, Pylint is installed. Beautiful. In the next lecture, I will show you how linting works. In this lecture, I'm going to show you linting in action. So let's start by writing some invalid code like this. Print space with no parentheses and then hello world. Earlier I told you that print is a built-in function, and whenever you want to use or call a function, you should always use parentheses. Now to be more precise, this is actually valid Python 2 code, but because we're using Python 3 here, this is invalid code from Python 3's point of view. So now when I save the changes, you can see this red underline here. Let's hover our mouse over this underline. You can see this tooltip. It's coming from Pylint, and here's the error message. Missing parentheses in call to print. Did you mean print with parentheses? So this is the benefit of linting. As you're writing code, you can see potential problems in your code. You don't have to wait to run your program to see these errors. So now, if we put parentheses here and save the changes, you can see that red underline is gone. Let's look at another error. Let's type 2 plus and then save the changes. Earlier, we ran this code in Python interpreter's interactive shell. There, we got a syntax or grammar error. So if you hover your mouse here one more time, you can see Pylint is telling us that this is invalid syntax or invalid grammar. It's like an incomplete sentence. So this is linting in action. Now let me show you a couple useful shortcuts here. On the top, look at the view menu. Here we have this problems menu. Look at the shortcut. On Mac, it's Shift, Command, and M. On Windows, it's probably Shift, Control, M. So as you're working with VS Code, try to memorize these shortcuts because they really help you write code faster. Now let's take a look at this problems panel. So this problems panel lists all the issues in your code in one place. So if you have an application with multiple files, this is really useful because some of those files may not currently be open. So this linter Pylint will analyze all your files, and if it finds any issues, it will list them here in the problems panel. Now you can also put this on the right side of the screen. So let's put it here. So as you write code, these problems will appear here. Now let's fix this issue. So I'm going to add 3 here, save the changes, and you can see the problem disappeared. And one last thing before we finish this lecture. Once again on the top, let's go to the view menu. The first item is command palette. This is a very important feature in VS Code. Once again, look at the shortcut that is Shift, Command and P on Mac or Shift, Control P on Windows. With this command palette, you can execute various commands in VS Code. If you type lint here, you can see all commands related to linting. As you can see, all these commands are prefixed with Python because these commands come with the Python extension that we installed earlier. So these are additional features available to us in VS Code. The first command here is select linter. In this list, you can see various linters available for PyLint. So as you're reading tutorials or talking to other people, you will hear about linters such as Flake 8, MyPy, Pep8, and so on. Different developers prefer different linters. I personally prefer PyLint. That is the most popular one, and that is the default linter set in the Python extension of VS Code. If you're adventurous, you can try using other linters on your own. The difference between these linters is in how they find and report errors. Some error messages are more meaningful or more friendly. The others are more ambiguous. So that's all about linting. In the next lecture, we'll talk about formatting code. In Python community, we have a bunch of documents called Python Enhancement Proposals or PEPs. Here on Google, if you search for Python PEPs, you can see the list of all these PEPs under python.org/dev/PEPs. Let's have a quick look here. So here are the PEPs. You can see each PEP has a number and a title. The one that is very popular amongst Python developers is Pep8, which is a style guide for Python code. A style guide is basically a document that defines a bunch of rules for formatting and styling our code. If you follow these conventions, the code that you write will end up being consistent with other people's code. Now, if you have time, you can go ahead and read this Pep8 documentation. But if not, don't worry, because throughout this course, I'm going to explain the key things in Pep8. In this lecture, I'm going to show you a tool that helps you automatically format your code according to Pep8. So back in VS Code, let's write some Python code. X equals 1. Here I'm declaring a variable and setting it to 1. If you're not familiar with variables, don't worry. In the next section, you're going to learn about them. So according to Pep8, this code is considered ugly because by convention, we should add a space around this equal sign or the assignment operator. Now, since you're starting out with Python, you probably don't know these rules. So let me show you a tool that helps you automatically format your code. Let's revert this back to its original state. Now we need to go back to the command palette, remember? So it's right here under View, and the shortcut is Shift, Command, and P. Here, if you search for format, you can see this command, format document. The first time you execute this command, you're going to see this message here. Formatter AutoPep8 is not installed. So there are a bunch of tools for formatting Python code. The most popular one is AutoPep8. And this is the tool that this Python extension we installed uses to format our code. So let's go ahead and install this. Good. Now one more time, let's open up the command palette and execute format document. See, this tool automatically formats our code. Beautiful. Let's take a look at another example. I'm going to declare another variable, y, and set it to 2, and a variable with a long name, like unit underline price, and we set this to 3. Now, some developers have this habit of formatting their variable declarations like this. So they put all these equal signs in the same column. According to Pep8, this is considered ugly. So once again, let's format our code. That is better. Beautiful. Now let me show you a trick. Opening up this command palette and searching for format document every time is a little bit time consuming. So I'm going to show you how to have your file automatically formatted as soon as you save the changes. On the top, let's go to the code menu, preferences, and settings. Here in the search box, search for format on save. So we have this option, editor, format on save. Take this. Now back to app.py. I'm going to change the formatting of these lines, make them really ugly. Now, as soon as I save the changes, you can see my code is reformatted. Beautiful. So you have learned that in order to run this Python program, we'll have to open up the terminal window and run Python on Windows or Python 3 on Mac, and then app.py. This is a little bit tedious, so let me show you a shortcut. Once again, let's go to the extensions panel. Here, search for code runner. There are multiple code runners out there. The one that I'm talking about is this one with the yellow icon. So go ahead and install this and then reload VS Code. Now, instead of opening up the terminal and manually typing Python app.py, all you have to do is to press Ctrl, Alt, and N. You can see the output here. Beautiful. Just be aware that if you make any changes, you will have to save the changes before using this shortcut. Otherwise, you're going to see the old result. Now, there is a tiny problem here. So you can see this is the command that is executed to run this Python program. So by default, this command is using python-u, and here is the name of our file. If you're on Windows, that's perfectly fine. But if you're on Mac, you know that Python refers to Python 2. Here we want to change this to Python 3. This is very easy. Once again, on the top, under the code menu, let's go to Preferences, Settings. And then here, under this ... go to open settings.json. Now here in the search bar, type code-runner.executor map. So these are the default settings used by this code runner extension. You can see this extension supports executing code in a lot of languages like JavaScript, Java, and so on. Now, if you scroll down, here we can see Python, and in front of that, you can see the command that is used to execute Python code. We need to change this. However, we cannot change the default settings. We should change the user settings. So on the right side, after the last setting, type a comma, and then in quotes, type code-runner.executor map, and then press enter. This will automatically copy all the settings on the left side to the right side. Now we can easily change one of these. So here's Python. Let's change the command to Python 3. You only have to do this if you're on Mac. And by the way, sorry if I have mentioned Windows and Mac a few times throughout this course. That's pretty much it. We're not going to differentiate between Windows and Mac in the future. So save the changes and we're done. When we talk about Python, we mean two separate things that are closely related: Python language and a particular implementation. Python as a language is just a specification that defines a set of rules and grammar for writing Python code. A Python implementation is basically a program that understands those rules and can execute Python code. Earlier in the course, we downloaded Python from python.org. This is the default implementation of Python called CPython. It's a program written in C, that's why it's called CPython. So here in terminal, when we run Python, we get this CPython. This is the default implementation of Python. There are a few other implementations out there, such as Jython, written in Java, IronPython, written in C#, and PyPy, written in a subset of Python itself. As new features are added to the Python language, they are first supported by CPython because that's the default implementation, and then they will gradually come to the other implementations. In theory, if we give some Python code to any of these implementations, we should get the same result. But in practice, that's not always the case. Certain features may be available in one implementation but not another, or they may just behave a little bit differently in a particular implementation. Now you might ask, what is the point of this? Why do we have several implementations of Python? Wouldn't CPython be enough? Well, it's for the same reason that we have multiple operating systems, or multiple browsers, or multiple programming languages. After all these years, we programmers haven't agreed on a single programming language, and that's the same story with Python implementations. However, there is one technical reason behind these implementations that you should be aware of. Since Jython is implemented in Java, it allows you to reuse some existing Java code in a Python program. So if you're a Java developer and you want to import some Java code into a Python program, you should use Jython instead of CPython. Similarly, IronPython is written in C#, so if you're a C# developer and want to bring some C# code into a Python program, you will have to use IronPython. Next, we'll look at how exactly CPython executes Python code. The programming languages we use, like C, C#, Java, Python, these are all simple text-based languages that we humans understand. Computers don't understand them. They only understand machine code. So if we have some code written in C, we should convert it to machine code. And that's the job of a C compiler. So a C compiler is a program that knows how to convert or compile C code into machine code. However, this machine code is specific to the type of CPU of a computer. So if we compile a C program on a Windows machine, we can't execute it on a Mac. Because Windows and Mac have different machine code, just like how people from different countries speak different languages. Java came to solve this problem. Java compiler doesn't compile Java code into machine code. Instead, it compiles it into a portable language called Java bytecode, which is not specific to a hardware platform like Windows or Mac. Now, we still need to convert Java bytecode to machine code. So Java also comes with a program called Java Virtual Machine, or JVM, for doing this. When we run a Java program, JVM kicks in, it loads our Java bytecode, and then at runtime, it will convert each instruction to machine code. With this model, we can run Java bytecode on any platforms that have a JVM. We have JVM implementations for Windows, Mac, and so on. So the JVM implementation on Windows knows how to convert Java bytecode into machine code that a Windows machine can understand. C# and Python have also taken the same route, so they are platform independent. When we run a Python program using CPython, first it will compile our Python code into Python bytecode, then it will pass that bytecode to Python virtual machine, which will in turn convert it into machine code and execute it. This is how CPython works. In the last lecture, we talked about various Python implementations. I told you that if you want to reuse some Java code in a Python program, you should use Jython. Now let's see how Jython makes this possible. When you use Jython to run a Python program, instead of compiling your Python code into Python bytecode, it will compile it to Java bytecode. So you can take this Java bytecode and run it using Java Virtual Machine. And that's why you can import some Java code into a Python program when using Jython, because the end result is Java bytecode, which will eventually be executed by Java Virtual Machine. So that brings us to the end of the first section. If you have enjoyed this course so far, please like this video and share it with others. In the next section, you're going to learn Python basics in only 1 hour. I hope you enjoyed this section, and thank you for watching. Well, hello, Mosh here. Thank you for watching my Python tutorial. I wanted to let you know that this tutorial is the first 2 hours of my complete Python course, where you will learn how to use Python in real-world scenarios such as data analysis and visualization, automating repetitive, boring tasks that involve working with files and folders, spreadsheets, PDFs, data compression, sending emails, web crawling, consuming APIs like Yelp to get information about businesses, and much more. This course comes with a 30-day, no questions asked, money-back guarantee and a certificate of completion. If you're interested, click the link below this video to access the course. All right, let's start this section by a discussion of variables and the built-in primitive types in Python, including integers, floats, booleans, and strings. So here I'm going to define a few variables, starting with the first one, students count. Note that here, all the letters are lowercase, and we're using an underscore to separate multiple words. This is the naming convention we use in Python. So here we set students count to, let's say, 1,000. This is an example of an integer. Let's look at an example of a float. So we set rating to 4, let's say 99. Here's another variable, is published. We set this to true or false. Note that the first letter is uppercase. And finally, let's take a look at an example of a string. So we set course name to Python. Now in Python, you can use either double quotes or single quotes, or you can use triple quotes if your string is multiple lines. For example, here I can put triple quotes, and in between them, I can add a string that has multiple lines, okay? Now, one interesting feature in Python is that you can initialize multiple variables on the same line. For example, let's say we have coordinates like x and y. We can initialize these two on the same line. So we can set x comma y. We set it to 1 comma 2. This line is exactly equivalent to these two lines. So it's a shortcut. And finally, just like almost every programming language, we can set multiple variables to the same value. For example, we can set x and y to 1. So these are the basics of variables. Next, I'll talk about the dynamic nature of Python. In terms of typing, programming languages fall into two categories: static languages like C++, C#, and Java, and dynamic languages like JavaScript, Ruby, and Python. In static languages, when declaring a variable, we need to specify its type. For example, in C#, when declaring this variable, we need to set its type to an integer. So with this, the type of this variable will always be an integer. When we compile this program, our compiler knows that students count is an integer. So if we accidentally try to set it to, let's say, a boolean later on, the compiler will complain. This is how static languages work. In dynamic languages like JavaScript and Python, we don't have this behavior. So we don't set a type when defining a variable. We just define a variable by setting it to a value. So in dynamic languages, the type of a variable is determined at runtime. Now here, if you hover your mouse over students count, you can see this is an integer. So when working on a large complex program, if you want to know the type of a variable, you can simply hover your mouse over it. We also have this built-in function called type. We can pass a variable or an object to it, like students count, and then print this on the console. So let's run this program. You can see the type of students count is a class of integer. What is this? Python is an object-oriented language, so here we have the concept of classes. If you're not familiar with classes, don't worry, I'm going to talk about them in detail later in the course. All I want you to know now is that in Python, we have a class called int that represents integers. So all integers are instances of this class. Let's take a look at a few more examples. So here in this interactive shell, let's look at the type of a float. Once again, it's a class called float. Let's look at type of a boolean. This is also a class called bool. And finally, let's look at type of a string. That's a class called str. So here's the takeaway. Python is a dynamic language, which means the type of variables are determined at runtime as opposed to compile time. So in the last lecture, you learned that Python is a dynamic language, which means the type of variables is determined at runtime. So here we have this variable age set to an integer. Now we can reset this to a string. This is perfectly valid Python code. So if we print age and run this program, you can see our program is running successfully. Now, if you come to Python from a static language like C# or Java, you probably don't like this. But the good news is that in Python 3.6, we have a new feature called type annotation or type hinting. So we can annotate our variables with their type. So we add a colon here and then int for integer. Now, when I save the changes, everything is still valid. If I run the program, there are no errors because Python is a dynamic language. However, there is a new linter called MyPy that checks for these type annotations. So if you define a variable as an integer and then set it to a string, MyPy is going to complain. Let me show you. So open up the command palette and type select linter. Currently, you can see we are using pylint. In this list, select MyPy. Now, the first time you do this, you're going to see a message on the bottom right corner of the screen telling you that MyPy is not installed. So go ahead and install that. Now on line 2, you can see a red line under age. Let's have a look here. So MyPy is giving us an error, incompatible types in assignment. So this is all about type annotation or type hinting. So here we have this variable x set to 1. When we run this program, Python interpreter will allocate some memory to store this number 1. So our x variable is purely a label for that memory location. Let me show you. So here we have this built-in function called id. We can pass a variable here like x, and this will return the address of the memory location that x references. So now let's print this on the console. There you go. So this is the address of the memory location where we have stored number 1. Now, one thing you need to know about the built-in primitive types that I've talked about so far, like numbers, strings, and booleans, is that all these types are immutable, which means their value cannot change. So here, if we try to update x, Python interpreter is going to allocate some new memory to store the updated value. In other words, what we have at this original memory location will not be affected because integers are immutable. Let me show you this. So here, after we print the ID of x, I'm going to increment x and print its ID one more time. See what we get? We get 2 different addresses. So our x variable or x label was originally referencing this memory location. At this memory location, we have the number 1. Because integers are immutable, we cannot change the value at this memory location. So on line 4, when we update x, Python interpreter will allocate some new memory at this location, and then x will reference this new memory location. Now, because we don't have a reference to the original memory, at some point, Python garbage collector will automatically release this memory. So this is how immutable types work. Now let's see what would happen if x was set to a mutable type. Here's an example. So in Python, we have a concept called lists for storing a list of objects. So here we use square brackets to indicate that this is a list. We can add multiple objects here. Now on line 4, let's add a new number to this list. So we call x.append and pass 4 here. Now let's run the program one more time. So as you can see, the address is not changed because lists are mutable. So whenever we change them by adding new objects to them or removing existing ones, the changes are applied at the same memory location. So this is the difference between mutable and immutable types. Over the next few lectures, we're going to take a closer look at strings. So here we have a variable of type string. To get the number of characters in this string, we use the built-in len function. Now look at the IntelliSense. This function returns the number of items in a container. So it's not specific to strings. It's a generic reusable function. We can pass a string here, and this will return the number of characters in the string, or we can pass a list, and this will return the number of items in the list. So here, let's pass this course variable and print the length. So we have 18 characters. Beautiful. Similar to many other languages, we can access individual characters using square bracket notation. So to get the first character, we use square brackets 0, because the index of the first character here is 0. Now let's print this, run the program, so we get P. Now, one interesting feature in Python that I personally haven't seen in other programming languages is a negative index. So here, let's duplicate this line and pass -1. What do you think we're going to get? Well, if 0 represents the first character, -1 takes us back to the end of the string, so it returns the first character from the end of the string. Let's run this program. So we get G. Similarly, we could pass -2, and this will return the second character from the end. Very powerful. Now, using a similar syntax, we can also slice strings. So let's duplicate this line. To slice the string, we need to pass 2 indexes: the start index, colon, the end index. So this will return all the characters starting from the start index all the way up to the end index, but it doesn't include the character at the end index. In this example, it's going to return 0, 1, and 2, these 3 characters, but not the character at index 3. Okay, so let's run the program. We get the first 3 characters. Beautiful. Now we can exclude either or both these indexes, and Python will assume default values. So let's duplicate this line and exclude the start index. What do you think Python is going to put here? It's common sense. It's going to pass 0 as the start index. So let's run the program. You can see we get the same result. So these last 2 expressions are exactly the same. Now, what if we exclude the end index? What do you think Python is going to put here? It's going to pass the length of the string. So let's run the program. You can see this returns the entire string. And finally, if we exclude both the start and end index, again, we get the same result. So let's verify this. Beautiful. Now, one thing you need to take into account here is that whenever we access an individual character or a range of characters, Python interpreter is going to allocate some new memory and copy those characters into that new memory location. Because as I told you before, strings are immutable. So the value that we have at the original memory location, that is Python programming, will not be affected. We can verify this. So let's print ID of course, and then print ID of course of 0. And then run the program. You can see 2 different addresses here. That is because strings and other primitive types like numbers and booleans are immutable in Python. Here we have this message variable set to the string, Python programming. Now let's say we want to display a double quote right here. The problem we have is that this second double quote indicates the end of the string, so Python interpreter will not be able to run this code. Now, there are 2 ways to solve this problem. One way is to replace these double quotes at the beginning and end of our string with single quotes. So single quote here and one more here. If we run this program, we see this double quote just before programming. Beautiful. But let's say for whatever reason, we want to use double quotes here, perhaps to be consistent with the rest of our code. So how can we display another double quote in the middle of the string? Well, in Python, we have a concept that is borrowed from the C language that is called escape character. So in Python strings, backslash has a special meaning and we refer to it as an escape character. So Python interpreter sees this backslash as a special character. It has a special meaning, And depending on the character that comes after that, it will interpret it differently. Let's see this in action. So now when we run this program, we can see our double quote here, but the backslash character is not there because backslash is an escape character. So in this case, it's used to escape the double quote. Now we refer to these two characters as an escape sequence. In Python, we have a few other escape sequences that you should be aware of. Let me show you. So this hash sign is an indication of a comment line, so it's not executed. You have seen backslash double quote. We also have backslash single quote for displaying a single quote in our string. We also have double backslashes. So if you really want to have a backslash in your string, you should prefix it with another backslash. Here is an example. Let's run this program. And here's our backslash. And finally, the last escape sequence is backslash n, which is short for new line. So here, if I add a backslash n and run this program, you can see programming is on the second line. Now, this is okay for a simple string like Python programming here, but if you're trying to format a complex string into multiple lines, it's better to use triple quotes. Otherwise, you will end up with a lot of backslash n sequences, and that looks pretty ugly. So here we can use triple quotes and simply add Python, new line, programming. So when we run this program, we get exactly the same result as before. Well, not quite exactly, because here we have one new line on the top. That is because I put Python on a new line. If I put Python right in front of double quotes, run the program again, that new line disappears. So here are the escape sequences in Python. Here we have two variables, first and last. Let's say we want to print my full name on the console. So we can define another variable, full, set it to first, then concatenate it with a space, and one more time concatenate it with last. Now when we print full, we get my full name on the console. Beautiful. Now this approach of using concatenation to build a string is okay, but there is a better and newer approach. We can use formatted strings. So here we can set full to this string and prefix it with an f, which can be lowercase or uppercase. This formatted string doesn't have a constant value like these two strings here. It's actually an expression that will be evaluated at runtime. So here we want to add our first name. We use curly braces to print the value of the first variable. After that, we add a space, and then we add curly braces one more time to print the last name. So at runtime, this expression will be evaluated. What we have in between curly braces will be replaced at runtime. Now let's run this program one more time. We get the exact same result. Just be aware that you can put any valid expressions in between curly braces. So earlier you learned about the built-in len function. We can call len here to get the length of this string. Let's run this program one more time, so we get 4. We can also replace last with an expression like this, 2 plus 2. Let's run this program, we get 4 and 4. So when using formatted strings, you can put any valid expressions in between curly braces. In this lecture, we're going to explore a few useful methods of string objects in Python. So this course variable we have here is a string object, which means we can use the dot notation to find all the methods or functions applicable on strings. Here we have a large list of functions, or more accurately, methods. In this lecture, I'm going to quickly show you a few of them. You can learn about the rest on your own. So here, let's say we want to convert this course to uppercase. We can use the upper method and print the result, and we'll get this uppercase string here. Similar to that, we have lower to convert it to lowercase. We also have title, which will convert this to title case, which means the first character of every word will be uppercase. And this is useful for blog posts, product titles, courses, and so on. So let's run this one more time. We get this string here. Another useful method is strip for trimming white space. So if we have a couple of extra white space at the beginning or end of this string, we can get rid of them using the strip method. And this is useful when you get input from the user. So print course.strip, save the changes. Note that in the previous examples, you can see those extra white spaces at the beginning, but when we call the strip method, those spaces are gone. We also have left and right strip for removing the white space from the beginning or end of this string. Now, if you want to find the index of a character or a substring in your string, you can use the find method. So let's print course.find. Let's search for pro. Run the program. So the index of pro here is 9. Now, if I change this to lowercase p, we'll get -1 because string comparisons are case sensitive and we don't have these exact 3 characters in our course variable. Now, if you want to replace a character or a sequence of characters, you can use the replace method. So let's print course.replace. Let's replace all capital P's with a hyphen. And with this, we'll get this weird string here. And finally, to check for the existence of a character or a sequence of characters in your string, you can use the in operator. So let's see if we have programming in this course object. Let's run the program and we get false because I realized that I missed the letter R here. So let's run the program one more time. This time we get true. Now we also have the not operator, so you can prefix this with not. And this time we'll get false. So we have covered strings. Now let's look at numbers. We have a few different ways to represent numbers in Python. We can use decimal numbers that you have seen before. We can also represent them in binary format. So we prefix the number with 0b, as in short for binary, and then we'll add individual bits. For example, 0b10, which is the number 2 in binary system. Now let's print x. We'll get 2. If you want to print the binary representation of this number, you can use the built-in bin function. So bin takes any numbers and returns its binary representation. There you go. We can also represent numbers in hexadecimal format. So we set x to 0x as the prefix, and then we'll add our hexadecimal number. Let's print x. So we get 300, which is in the decimal system. If you want to print this in the hexadecimal format, you would use the built-in hex function. Let's run this program one more time. And now we get 0x12c. Beautiful. In Python, we also have support for complex numbers. So complex numbers in math take the form a plus bi. If you're not familiar with this, don't worry. This is a concept used in mathematics. So if you want to use Python to build web applications, you're never going to use this. But very briefly, let me show you how you can represent complex numbers in Python. So here we can set x to 1 plus 2j. So j in Python is like I or imaginary number in math. You can use either lowercase or uppercase j, whatever you prefer. Now let's print x. We'll get this complex number here. In Python, we have all the arithmetic operators that you have probably seen before. For example, we can set x to 10 plus 3. We have addition, we have subtraction, multiplication, division, but we actually have two kinds of division operators. Let's look at the first one. So print x. As you can see, the result of this division operator is a floating point number. If you want an integer, you would use a different division operator, that is double slash. Let's run this program. So we get 3. We also have modulus, so that is the remainder of a division. And finally, we have exponent, that is left to the power of right. So here, 10 to the power of 3 is 1,000. Now, for all these operators here, we have an augmented assignment operator. What do I mean by that? Let's say we want to add 1 to x. We can write a statement like this. So x equals x plus 1, or we can use an augmented assignment operator. So x plus equals 1. These two statements are exactly the same. And what we have on the left side of the assignment operator can be any of these arithmetic operators here. And one last thing before we finish this lecture. In Python, unlike languages like JavaScript or C#, we don't have the increment or decrement operators. So we don't have x plus plus or x minus minus. In this lecture, I'm going to show you a few useful functions for working with numbers. So let's set x to 3.14, or actually let's rename this to pi. Note that here I have used uppercase letters to indicate that this is a constant. In Python, unlike languages like C# and JavaScript, we don't have constants. We only have variables. So if we define this, there is nothing that stops us from changing the value of this variable. So by convention, we use uppercase letters to tell other developers in the team that this pi is a constant and it shouldn't be modified. Now, let me show you a few useful built-in functions to work with numbers. If you want to round a number, you can use the round function. So let's pass pi here and print it. So we get 3. We have another useful function, ABS, short for absolute, and it returns the absolute value of a number. So if we add a minus sign here, when we print this, we'll get 3.14. Here you go. Now, to see the complete list of built-in functions in Python, here in Google, search for Python 3, make sure to add the version number, and then add built-in functions. On this page, you can see all the built-in functions in Python. Now, in this list, we only have a few functions to work with numbers. If you want to perform complex mathematical computations, we have a separate module for that. That's the math module. So back to our code. On the top, first we need to import the math module. Now, math is an object with a bunch of useful methods for performing mathematical computations. So here we can use the dot notation to see all these methods available to us. For example, we can use math.floor to get the floor of pi. And this returns -4 because here we are using a negative sign. If you want to see the complete list of functions or methods in the math module, search for Python 3 math module. Here on this page, you can see all the functions and their description. Quite often when we receive input from the user, that input comes as a string, and there are times that we need to convert that string to a different type. Here's an example. We have this built-in function input. We can add a label here like x. This returns the user's input as a string, so we store it in this variable. Now let's imagine y should be x plus 1. Now when we run this code, we're going to get an error. Let me show you. Don't run this using the code runner Because CodeRunner runs this code in the output window, which is read-only, so you won't be able to enter a value. So open up the terminal by pressing Control and backtick, and run Python if you're on Windows or Python 3 if you're on Mac, app.py. Let's add one here. Look, we get this error, type error. This is happening because Python doesn't know how to interpret this expression, because here we have two different outcomes. If x is the string 1, one outcome is to convert this other operand here to a string, and the result would be 11. The other outcome is to convert x to a number, so we'll have 1 plus 1, and the outcome will be 2. So Python doesn't know how to do type conversion here. And that's the reason we say Python is a strongly typed language, because it doesn't do any implicit type conversion on your behalf. You have to explicitly tell Python how you want your objects to be converted to the right type. JavaScript, on the other hand, is a weakly typed language, so it does perform implicit type conversion for you. Now, to solve this problem, we need to use one of the built-in type conversion functions. We have int, float, bool, and str or string. Now, in this case, we don't need to use string here because we already have a string and there is no reason to convert a string to another. But there are times that you may want to convert an object to a string. So just be aware of this function. Now, let's take a look at what these functions return. And let's delete line 2 because this is the bad boy here. Save the changes. Back in the terminal, let's run the application one more time and enter 1. So here's what we get. Number 1 as an integer, 1.0, which is a float, and true. So int and float are pretty self-explanatory, but bool requires a little bit more explanation. Because in Python, similar to JavaScript, we have this concept of truthy and falsy values. So here are the list of falsy values. Empty strings, number 0, empty lists, and none, which is an object that represents the absence of a value. This is exactly like null in C-based languages. So if we have any of these values and we try to convert them to a Boolean using the bool function, the result will be Boolean false. Anything else would be true. Let's take a look at a few examples. So here in the interactive shell, I told you that number 0 is considered falsy, so when we convert it to bool, we'll get false. Any other numbers are true or truthy. So here's an example, bool 1 is true. If we add a negative number, we also get true. As for strings, an empty string is falsy, so we get false. Any other strings is truthy. So even if I add the string false here, the result is true because this is a non-empty string. So here are the falsy values in Python. Whenever these values are used in a Boolean context, they will be equivalent to Boolean false. All right, now let's talk about conditional statements. So I'm going to start by defining a variable age and setting it to 22. Now let's see if age is greater than or equal to 18. So in Python, we have these comparison operators, just like the other languages that you have worked with. We also have equal and not equal. Now let's revert this back to greater than or equal to 18. Now here's an interesting fact about Python. In Python, we don't have braces, which means we're not going to spend 2 decades fighting over where to put these braces. Shall we put them here or here? No more nonsense like that. It's over. That's it. No more. So instead, we put a colon at the end of this line. Now note that when I press enter, this cursor is automatically indented. So we use indentation to specify a code block. Here we can add a print statement, adult, we can have another print statement. This is also part of this block. Now to terminate this block, we simply remove the indentation. Now here we can have 0 or more else if blocks. In Python, we call them elif. Here we add another condition like if age is greater than or equal to 13. Once again, we have indentation. Let's print teenager. And finally, optionally, we can have an else block. Once again, colon, print with one or more statements. In this case, we want to print child. Finally, we'll have, let's say, all done. Now, note that currently we have 2 spaces for indentation. But when I save the changes, AutoPEP8 kicks in and reformats our code according to PEP8. According to PEP8, we should use 4 spaces for indentation. Take a look, save the changes, now we have 4 spaces. You can also use tabs, but only if you're maintaining a code that is written with that style. If you're starting a new project, prefer 4 spaces as the standard, but you cannot mix tabs and spaces in Python 3. That's not allowed. Now let me show you a shortcut. So here in a new file, let's just type if, look at these 3 items with this square icon. These are code snippets. So here on if else, I press enter and this automatically generates this snippet. This came with the Python extension that we installed at the beginning of the course. So here we can change the condition to whatever, x is greater than 1. What is this pass keyword? This is basically a statement that doesn't do anything. It's here purely to fill this if block because we cannot have an empty if block like this. If I save the changes, look, we have this red underline here. That is not valid Python code. So if you want to have just an empty block, you use the pass keyword. In Python, just like the other languages, we have 3 logical operators. We have the logical AND, the logical OR, and NOT. Let's take a look at a few examples. So I'm going to start by defining a variable name, setting it to Mosh. Now, let's say this is the input that we get from the user. We want to check to see if name is an empty string. How do we do that? Well, earlier I talked about the falsy values in Python. So we have 0, empty string, none, and an empty list. These are all considered falsy. So let's talk about an empty string. If this is interpreted as false, then if we apply the not operator on it, we'll get true, right? So to check to see if name is an empty string, we can simply write a statement like this. If not name colon. That's it. Print name is empty. Now let's run this program. Obviously, we don't get that message. However, if I change this to an empty string and rerun the program, we get name is empty. But what if I add a white space here? Well, white space is not considered truthy because it's not an empty string. So look, if I run the program, we don't get the message. To fix this issue, we can simply call .strip method to get rid of all the white space. Now, let's run it one more time. Beautiful. So this is our not operator. Let's take a look at an example of AND. So I'm going to set age to 22. Now let's see if age is greater than or equal to 18 and age is less than 65. We say you are eligible. Good. Pretty easy, right? Now here's a question. How do we write that expression in math? We write it like this. Well, more accurately, we should add the equal sign here. So age is between 18 and 65, right? I have good news for you. In Python, you can simply write this expression. That's perfectly fine. This is what we call chaining comparison operators. So we can rewrite this expression in a simpler and more meaningful way. This is one of the reasons that Python is a highly popular language because the syntax is so clean, without any clutter, it's easy to understand, and it comes with all these best practices and standards for writing clean code. So let's rewrite this to 18 like this. Good. Now let's run the program. Obviously, this person is eligible. So here we have this piece of code similar to what we wrote in the last lecture. If the person is 18 years or older, we set the message to eligible, otherwise we set it to not eligible. In C-based languages, we have this operator called ternary operator that allows us to rewrite this piece of code in a more compact way. Let me show you how that looks like. So we set message to, we add our condition. So if age is greater than or equal to 18, we add a question mark. If that is true, we set the message to eligible. Otherwise, indicated by a colon, we set it to not eligible. If you have worked with C#, JavaScript, C++, Java, you have seen this before. If not, don't worry. Let me show you the Python way. So in Python, we can rewrite this expression almost in plain English. So message is eligible if age is greater than or equal to 18. Otherwise, it's not eligible. Isn't that easy? So this is the ternary operator in Python. In Python, we have two types of loops. So unlike some languages that have 4 or 5 different kinds of loops, here we only have 2 types. We have for loops and while loops. Their syntax is very simple and clean. Let me show you. So we start with the for loops. With for loops, we can iterate over any object that is iterable. Here are a few examples. We can iterate over strings. So for x in Python, because strings in Python are iterable, which means we can iterate over them. So in each iteration, our loop variable x will hold 1 character. Let me show you. So we terminate this line with a colon, just like our if clauses. Now we use indentation to specify the block of statements. So we simply print x. Run the program. This is what we get. Here's another example. We can loop over lists. So let's say we have a list of names, A, B, and C, colon, print x. There you go. So we get A, B, C here. Now, what if we want to loop over a sequence of numbers? That's when we use the built-in range function. Let me show you. So for x in, we call the range function pass a number like 5. Look at what happens. Now, to keep this example clear, I'm going to comment out these few lines. So the shortcut on Mac is Command and slash. On Windows, it's Control slash. Now, let's run this program. So when we call range of 5, we get numbers 0 to 4. We can pass a starting number like 2 to 5. Let's run this one more time. So now we get 2, 3, 4. We can also pass a third argument here called step. Let me show you. So I'm going to change this to 0 to 10. Let's say we want to display all the even numbers between 0 to 10. So we pass 2 here. That is our step. Now when we run the program, we get 0, 2, 4, and so on. Now, one thing you need to understand about this range function is that it does not return a list. Let me show you. So I'm going to comment out these 2 lines as well. Let's just print range of 5. What do we see? We see range of 0 to 5. We don't see a list object. In contrast, if we had a list like 1, 2, 3, 4, 5, see? This is how we see a list printed in the terminal. So what is returned from the range function is not a list. It's a different kind of object. It's a range object. Let me show you. So here, I'm going to call the built-in type function. Now, let's look at the type of this object. It's an instance of a class called range. So our range function returns a range object. Range objects in Python are iterable like strings and lists, so we can use them in for loops. Now, what is interesting about these range objects is that they take a very small amount of memory. So here, if we pass, let's say 5 billion, we are not going to get a list of 5 billion elements. We have a small object that can be iterated over. In each iteration, it will produce a new number like 1, 2, 3, 4, and so on. In contrast, if we had a list of 5 billion items, that list would take significant amount of memory. So this is the difference between list and range objects. So here we have a list of names. Let's write a simple program and check to see if we have a name that starts with J in this list. So we can use our for loop for name in names. Now, if name that starts with J, perhaps we want to display a message like found. Now, if this list has a million objects, as soon as we find the first object, we want to jump out of this loop. We don't want to continue looping for performance reasons. So this is where we use the break statement. You have probably seen this before. When Python interpreter sees this statement, it will terminate this iteration. So now we jump out of this loop. Let's add another scenario to this program. If we loop over all the names in this list and we don't find a name that matches our criteria, perhaps we want to display a different message to the user like, hey, we couldn't find a name that starts with J. So typically how we implement this in other programming languages is like this. On the top, we define a flag like found and set it to false. Then here, as soon as we find an object that matches our criteria, we set this flag to true. And then after our for block, we check to see if not found, we print not found. Let's save the changes. Good. Run the program. Obviously, we have a name that starts with J, so found, beautiful. Now let's change this to A John. Run the program, not found. So our algorithm is working properly. But in Python, there is a cleaner way to implement this scenario. We don't need this found flag. So let's delete it from here and here. All we have to do is to get the same result is to change this statement to else. So we have 4 else blocks in Python. This else clause is executed if our for loop completes successfully without an immediate break. So if we iterate over all the objects in this iterable, then this else clause will be executed. So now, when we run this program, we get the exact same result. The other type of loops we have in Python are while loops. So let's build a simple guessing game. I'm going to define 2 variables, guess set to 0, and answer set to 5. Now we can write a while loop like this. While answer is not equal to guess, once again colon, here we have indentation, we can get the input from the user, make a guess. Now as you know, this returns a string, so we need to convert this to an integer and then store it in the guess variable. Now as I told you before, this code runner extension runs our code in the output window, which is read only, so we cannot enter values there. To fix this issue on the top, let's go to Preferences, Settings, then click here and open settings.json. Now here we need to add a new setting that is code-runner.run in terminal. By default, it's false. We need to set this to true. Save the changes. Now when we run this program using code runner, it runs it in terminal. So here in terminal window, let's add a number like 1, 2, 3, 4. As soon as we enter 5, the game stops. So this is our while loop. Similar to for loops, we have an else block here. We can optionally use that. This is only executed if the while loop completes successfully without using a break statement. To define a function, we start with the keyword def, which is short for define or function definition. Here you can see we have a few code snippets. The first one is for defining a function. So just press enter. So here's the basic syntax. We start with the function name, like increment. Now press tab. In parentheses, we define parameters, if they exist. In this case, let's add a couple of parameters like number and by. So we want to increment a number by a given value, right? Also, you can see this line is terminated by a colon, and right after that, we're using indentation to specify the body of this function, just like our if and for clauses. Now we can call this function like this. So increment, parentheses, give it a couple of values like 2 and 3. Now note that when I save the changes, you're going to see 2 line breaks after this function. So save, there you go. So we have 2 line breaks because that's the style that PEP 8 defines. So we should always have 2 line breaks after our functions. Now these functions by default return the none or null value. So even though we don't have a return statement here, this function is still returning a value. Let me show you. So print the return value of increment and run the program. Look, we get none. Now let's return a value like number plus by. Run the program again. Now we get 5. Beautiful. In Python, unlike many other languages out there, we can return multiple values from our functions. We simply put them in parentheses. So here we add parentheses. Let's say we want to return the original number as well as the updated number. So number, comma, number plus by. Now let's see what we get when we run this program. So run it. So in parentheses, we get 2, which is the original number, and the updated number. What is this? This is what we call a tuple, which is basically a read-only list. So earlier in the course, you have seen lists like numbers. We use square brackets, 1, 2, 3. This is a list. We can add new objects to it. We can remove existing objects. A tuple is like a list, but we cannot modify it. So we cannot add new objects to it. We cannot remove existing objects. Now, to convert this list to a tuple, we use parentheses instead of square brackets. Okay? Delete. Another useful feature we have here is called keyword arguments. So currently, if someone looks at this code, they may not be able to tell what exactly these arguments are for. We can use keyword arguments to make our code more readable. For example, here, we can prefix this second argument with something like this, by equals. Now we can read this code like plain English, increment 2 by 3. So this is what we call a keyword argument. It's just a way to make our code more readable. Also, similar to a lot of languages out there, we can assign default values to these parameters. For example, we can set a default value for the by parameter. So now we don't have to pass a second argument here. And when we run this program, the value of by will be set to 1 by default. And one last thing before we finish this lecture. Earlier I talked about type annotation or type hinting. We can use that feature in our functions as well. So here we can annotate these parameters as well as the increment function itself. So here we add colon int for integer, and here also colon int. And finally, for the function itself, before this colon that terminates this line, we need to add an arrow, and then we'll add the return type of this function, so integer as well. Now, in this case, we have a red underline here because I annotated this function to return an integer, but I'm returning a tuple. So more accurately, this should be tuple. Save the changes and the error is gone. There are times that you may want to pass an arbitrary number of arguments to a function. Here's an example. Let's say we have a function called multiply that currently takes two parameters, a and b. And this function would simply return a times b. And then we can call it like this. So far, so good. But what if we want to pass a variable number of arguments here, like 4 and 5? Well, one way is to put these arguments in a list. Then we need to replace these two parameters with a list. And we should also change the implementation of this function. Here we need a loop to iterate over this list and multiply all its elements. That is perfectly fine. However, this syntax is a little bit noisy. Wouldn't that be nicer if we could pass these numbers or these arguments here without these additional square brackets? Let me show you how to do this. So all we have to do is to prefix this parameter with an asterisk. Now let's print list and see what we get when we call the multiply function. So save the changes, run the program. What do we get here? We get a tuple because of this parenthesis. So when we add an asterisk before a parameter, Python will see that parameter as a tuple. So when we pass an arbitrary number of arguments, Python will automatically package them into a tuple. Now, as I told you before, a tuple is like a list. So we can loop over it, get all the numbers and multiply them together. Let me show you real quick. So we start by defining a variable, total, we set it to 1. Next, we need a loop. So for number in list, colon, here we simply do total times equal number. And finally, we return total. Save the changes. Good. Run the program. Actually, I forgot to print the results, so let's print it here. Run it one more time. So here's the total. In the last lecture, you learned about the syntax for passing a variable number of arguments to a function. We have a variation of this syntax, and that's what I'm going to show you in this lecture. So let's start by defining a function. Call it save user. Here we add one parameter, user, but instead of one asterisk, we use double asterisks. So first, let's print this user parameter here and see what we get when we call this function. So save underline user. Now, instead of passing an arbitrary number of arguments here, we should pass an arbitrary number of keyword arguments. Remember keyword arguments? Name equals value. So here we can pass multiple properties about a user. For example, we can pass ID equals 1, name equals admin, and so on. So here we have 2 keyword arguments. Let's run this program and see what we get when we call this function. So save the changes and run. This is what we get. Look at the syntax. Here we have curly braces, and in between them we have multiple key value pairs. Here's the first one, here's the second one. This is what we call a dictionary. If you're a JavaScript developer, this syntax is familiar to you. This is like an object in JavaScript. Now, if you're not familiar with JavaScript objects or dictionaries in general, don't worry. Later in the course, we have a comprehensive section about data structures in Python, and there I'm going to cover lists, tuples, dictionaries, and so on. Now, to finish up this example, here we can use square bracket notation to get the ID or name of a user. Let's run this program one more time. So ID is 1 and name is admin. Beautiful. In Python, we have 2 types of variables. Local variables with the function scope and global variables with the file scope. So in this example, This message variable is a local variable in the greet function. Its scope is the greet function, so we can access it anywhere in this function. Now, in Python, unlike languages like C# or JavaScript, we don't have block level scope. So if we define this variable inside of an if block, it is still accessible outside of that block. Let me show you. So here I'm going to add if true colon. Inside of this if block, we're defining the message variable, but it's still accessible outside of the if block. So here we can print message. The same applies if we have a loop here, a for loop or a while loop. So in Python, we don't have block level scope. No matter where we define a variable in a function, it is always accessible in that function after it is defined. So that's all about our local variables. Now let's talk about global variables. If we put this message variable outside of this function, now it's a global variable, so it's accessible anywhere in this file, in any functions. So here in the greet function, we can print it on the terminal. Let's take a look. So here we call greet, run the program, we get A. Now let me show you something interesting. Here in the greet function, I'm going to assign a new value to the message variable. Let's set it to B. Run the program again. Obviously, we get B. However, if I bring this print statement outside of this function and run the program again, let's see what happens. We get A. What's going on here? Didn't we change the value of the message variable? Not really. In this case, this message variable becomes a local variable in the greet function because by default, Python enforces good programming practices. As you probably know, global variables are evil. We shouldn't change them in a function because this can cause a side effect in other functions. So in this case, when Python interpreter sees line 5, it will create a new local variable called message, even though it has the same name as our global variable on line 1. These two are completely separate. Now, I've seen some tutorials and books teaching you bad programming practices. They show you how to modify the value of a global variable inside of a function. So this is how we do it. We use the global keyword and reference the message variable. When Python interpreter sees this, it will realize that in this function, we don't want to create a local variable. We want to use the global message variable that we defined earlier. Now, if we run this code, instead of A, we're going to get B, because the changes will be visible after we exit this function. And that is the reason I said you should avoid using global variables, or if you really want to use them, make sure not to modify them inside of a function, because this can create a side effect in other functions. Maybe other functions rely on the original value of that variable. So, avoid using the global statement. It's a bad practice. It's evil. All right, let's finish up this section by looking at debugging in VS Code. So I have this simple program with this multiply function that we talked about earlier. If you want to follow along with me, head over to bit.ly/pygist, G-I-S-T. Here on GitHub, you can see my gist. Simply copy paste this code. We're going to use this code to explore debugging in VS Code. So below this function, we have 3 statements to print start, the result of calling the multiply function, and print finish. So to start debugging, first we need to add a breakpoint. So here on line 8, you can use your mouse to put a breakpoint here, or if you have taken any of my courses before, you know that I always put a lot of emphasis on using your keyboard because professional developers use their keyboard, not their mouse. So using F9, you can add or remove a breakpoint. Now open up the debugging panel. Here on the top, click this icon here. This will create a JSON file called launch.json with a bunch of configuration for debugging. You can see this file in the project folder inside of this VS Code folder. Here's launch.json. Now you never have to touch this file. We just have to create it the first time. Now let's close this. Back to the debugging panel. Now, after this file is created, in this drop-down list, you can see various configuration options for a debugging session. From this list, select Python, current file, integrated terminal. So we're going to debug the current file in the terminal that is integrated inside of VS Code. There is also another one with an external terminal. Now to start a debugging session, press F5. So here on the right side, you can see my integrated terminal. I'm going to close this because it's cluttering the view. So here is the breakpoint activated. Now we are on this line. We can step over it by pressing F10. If you're on a Mac keyboard, you should hold the function key that is on the bottom left corner of your keyboard. So step over. Now on line 9, we are calling a function. So we want to step into this function to see what is going on there. For this, press F11. Now here we are inside of the multiply function. On the left side, inside the variables panel, you can see the variables that are local in this scope. So we have numbers, which is the argument passed to this function. Let's step over one more time at F10. Now we are at the beginning of our loop. One more time F10. Now at this point, you can see a few other variables here. So we have our total. We have the current number that is picked in this iteration. You can also create watches here if you want to look at the value of a variable that is not listed in this panel. Now, let's say you inspected all the variables and you want to step out of this function. To do that, press Shift and F11. Now we are out, back on line 9, F10 one more time, and one more time, and the debugging session is finished. All right, let's finish up this section by looking at a few very useful shortcuts for writing code fast. First, I'm going to show you the shortcuts for Windows users, and in the next lecture, we'll look at the shortcuts for Mac. So if you're a Mac user, feel free to skip this lecture. So here we're on line 9, and my cursor is right at the beginning of the line. Let's say we want to move the cursor to the end of the line. Instead of pressing the right arrow to go all the way to the end, we can simply press the End key, and here's the cursor. Or if you want to move the cursor to the beginning of the line, simply press the Home key. There you go. Similarly, if you want to move the cursor to the beginning of the file, press Control and Home. Here it is, or Control and End to go to the end of the file. Now let's say we want to move this line up. Instead of cutting it from here and then copying it somewhere else, we can simply move it up by pressing Alt and the up or down arrows. Or if you want to move these two lines up and down, simply select them, then hold Alt and then up or down. Very easy. Now, if you want to duplicate a line or multiple lines, simply select them. Now hold down Shift, Alt, and then press the down key. You can duplicate it as many times as you want. There you go. Here's another useful shortcut. If you want to convert this line or maybe these two lines into a comment, simply hold down Control and press slash. Using the same shortcut, you can remove the comment, so you can toggle it. Very easy. And finally, if you want to type the name of a variable or a function like multiply, you don't have to type all characters. Here are a few ways to type this quickly. You can just type the first few characters, and here in the IntelliSense, you can see that. So if you press enter, this is what we call auto-completion. Here's another way. So instead of writing the first few letters, you can just pick any letters in sequence and type them. So I can type MTY, or I can just type MPY or MY. There you go. Here it is. So I hope you enjoyed these shortcuts, and thank you for watching. All right, now let's take a look at the shortcuts for a Mac keyboard. So here we are on line 9, and my cursor is right at the beginning of the line. If you want to move the cursor to the end of the line, instead of using the right arrow to go all the way, simply hold down the function key and press right. Here it is. Or you can press function and left to jump to the beginning of the line. Similarly, you can press function and up to go to the top of the file, or function and down to jump to the end of the file. Pretty useful. Now let's say you want to move this line up. Instead of cutting it from here and then copying it somewhere else, you can simply move it up by holding down Alt or Option and then pressing the up arrow or down. Very easy. Or we can select these two lines, hold down the Alt or Option key, move it up or down. Here's another useful shortcut. We can convert these two lines into a comment by pressing Command and slash, and then we can remove the comment using the same shortcut. So we can toggle it. And finally, if you want to type the name of a variable or a function like multiply, you don't have to type all the letters like multiply. That is very slow. You can type the first few letters like mult, and here in the IntelliSense, you can see it's selected, so press enter. Or you can pick any characters in sequence and type them, like MTY, here it is, or we can type MPY or MTP, so you can abbreviate it any way you want. I hope you enjoyed these shortcuts, and thank you for watching. One of the questions that often comes in programming interviews is the FizzBuzz algorithm. You might be surprised that there are a lot of developers out there with even years of experience, but they don't know how to solve this simple programming problem. That's why I decided to include this in my course. So let's see how this algorithm works, and then you can spend 10 to 15 minutes on this exercise on your own. So here we have a function, FizzBuzz, that takes an input, and depending on the input we give it, it returns different results. Here are the rules. If the input that we give it is divisible by 3, it will return the string fizz. Let me show you. So we run this program, we get fizz. If the input is divisible by 5, it will return buzz. Take a look. Here's buzz. Now the third rule. If the input is divisible by both 3 and 5, it will return FizzBuzz. So let's pass 15 here. We'll get FizzBuzz. For any other numbers, it will return the same input. So if I pass 7, it's not divisible by 3 or 5, it will return 7 itself. So spend 10 to 15 minutes on this exercise. You will see my solution next. All right, let's see how we can solve this problem. So we get the input and check to see if input is divisible by 3. Then we can set a variable like result to fizz. Now let me temporarily simplify these rules because I want to show you a really cool technique. So let's imagine if the input is divisible by 3, we'll return fizz. Otherwise, we'll return buzz. So else colon, we set the result to buzz, and finally we'll return this result variable. This is one way to implement these rules, but it's not the best way. There is a better and cleaner way. Let me show you. So instead of defining this result variable and then returning it, we can simply return this string here and also here, and then we can get rid of line 6. So we remove one unnecessary line of code. This was one technique. The other technique I want to show you is when you have an if statement and in your if block, you're returning a value, you don't really need an else clause. Because if this condition is evaluated to false, the control moves to the else clause, and all we are doing here is returning a different value. So this is the only possible outcome. So here we can remove this else clause and simply return buzz. So with this technique, I removed an unnecessary indentation as well. I've made our code more linear, okay? Now, let's go back to our original algorithm. So if the input is divisible by 3, we'll return fizz. Now we check to see if the input is divisible by 5, we'll return buzz. So here, we don't really need an elif, because if this condition is false, we'll get here anyway. So we can check if input is divisible by 5, we will return buzz. Once again, if this condition is false, the control moves here. Now we check to see if the input is divisible by 3 and it is also divisible by 5, then we will return fizz buzz. Now, this expression is a little bit long. I would prefer to make it more readable by putting parentheses around the first and second parts, like this. That is cleaner. Now, if this condition is also false, the control moves here. That means our number is not divisible by 3 or 5, so we should simply return the same input. Once again, we don't need an else or another if. We simply return the input. Now let's run this program and see if it's working properly or not. So we call our function with 3 and we get fizz, beautiful. Let's call it with 5. We get buzz, perfect. What if we call it with 15? We should get fizz buzz. However, we get fizz. What is going on here? The reason this happened was because when we pass 15 here, line 2 is executed. Obviously, 15 is divisible by 3, so that is why we immediately return fizz. To solve this problem, we need to move this condition, which is more specific, to the top. So I've selected these two lines using Alt and up. I move these lines up, beautiful. All right, now let's run the program one more time. So we get fizz buzz. Once again, let's test it with 3. Now we get fizz. Let's test it with 5. When writing functions, don't assume that your function is working. Make sure to test it with all different kinds of values. Let's test it with 5. We get buzz, beautiful. What if we pass 7, which is not divisible by 3 or 5? We get 7, beautiful. So what you see here is the simplest and most elegant implementation of the FizzBuzz algorithm. And that brings us to the end of this section. In the next lecture, we're going to explore data structures in Python. You're going to learn about lists, tuples, sets, and dictionaries. I hope you enjoyed this section, and thank you for watching. You made it this far, and that makes me think that you're really enthusiastic about learning Python. So I highly encourage you to enroll in my complete Python course, where we go way beyond this crash course. You will learn how to use Python in real-world scenarios, such as data analysis and visualization, automating repetitive, boring tasks that involve working with files and folders, spreadsheets, PDFs, data compression, sending emails, web crawling, consuming APIs, and much, much more. This course comes with a 30-day, no questions asked, money-back guarantee and a certificate of completion. If you're interested, click the link below this video to access the course. Once again, thank you for watching. Please support me by liking and sharing this video, and also subscribe to my channel to get free new videos every week. Thank you and have a great day.